Go over the V connector today and specifically something new that we've done to it to make it a better product. I'm going to go through a couple slides on configurations, how we construct it, and then a custom fabrication series where I'm going to show a large ID one that we did. Some interesting pictures are going to be up here. You guys can stop me as I go along if you have questions, just because I don't think there's going to be a lot of them, but feel free. My name is Marcus Kenna. I'm with Twin City Hose. You guys have one of my business cards. We are fabricators of metal flexible hose assemblies. So we buy metal hose, we buy braid, we buy end fittings, and we fabricate the assemblies in Rogers, Minnesota. Also metal expansion joints and rubber expansion joints, fabrication and distribution. We fabricate all of our metal hose assemblies and V connectors, which falls into that product for in Rogers, Minnesota, in the United States. We have an extensive facility with raw materials and finished goods, setup, shipping, testing, the whole 9 yards, and I'll go through all of that as we go through this. So the V connector is the most effective way to compensate for thermal growth, seismic, or random motion. The construction of the V connector, 2 legs of hose and braid. Now typically if you have just a metal hose assembly, it can't take thermal expansion contraction. All it can do is offset accommodation. But when we put it in this configuration, it's accommodating offset because we're putting all the motion this way into the V. It's 2 legs of flexible metal hose. That specifies the movement. We weld the hose, braid, and braid collar together, and then we'll put the end fittings on, the 90, 245s, and then whatever end configurations from our extensive warehouse. Today we're going to be covering Twin City Hose, what we did for the new design or new material for the V connector, the movements, cost things, custom fabrication, configuration options, and 100% testing. Our experience, we're a leading manufacturer in the HVAC industry, and we've done this over 35 years. We built a reputation on the reliability, the quality, lean lead times, fair pricing. We have 25 consecutive years exhibiting here at the AHR Expo. AS&E certified welders within the sales staff, inside and outside, 100 plus years of metal hose experience. So we've pretty much seen everything as far as metal hose is concerned, for applications, media types, pressures, across the board. Again, everything fabricated here in the United States. For the new design, we looked at the V and we said, how can we make the V connector, which is a good product, great? And we said, well, look, we have a vast amount of options on metal hose. We took a more flexible metal hose, which has more corrugations per inch, and we put that into the V connector. We were able to decrease the footprint of the V, which is decreasing the height, which allowed us to get into more applications. We also were able to do this with no cost increase on the V and better flexibility, obviously, as you shorten this live length of hose. All the info in all media types, written, printed, or on the web, has been updated to reflect the new construction of the V connector. Also on the V's, when we took this new hose, we were able to keep the same pressure ratings they have and or increase the pressure ratings, as well as temperature ratings stayed the same. So with the movements on the V, we do a 2, 3, and 4 inch custom move, or standard movement. That's our standard in our books. Dimensional information is there. We can do custom movements as well. We've done up to 11-inch movement V, so it increases that live length of hose and braid. To the left there on that picture, that's probably a 6 to 7-inch movement V on a 6-inch ID. So those are large movement Vs. And then right there, that's just a picture of a nested V. As you look at a V connector, and this is one of the benefits with the Vs, you can nest Vs very easily, where if you draw a V, you can write a V inside itself over and over with a hard pipe loop and or a flexible loop, it's a U. And when you do that, you're increasing material for every additional U you have within the consecutive pipe runs. So we're able to keep the price the same on each V connector. The prices don't increase and the movements stay the same. The V connectors are capable of the XYZ axis motion. So they'll take straight up axial motion in a guided application or a constrained application, or in an unconstrained application, that's seismic and random motion, where you start to get the Y and Z motion into it. With seismic and random, the V's have to be rated to the sum of all the movements within the V. So if you're seeing an inch of axial compression, an inch of lateral, and maybe an inch of horizontal, that's 3 inches movement. The V has to be rated to 3 inches, and in some instances, you could pad yourself and rate it for 4 inches or 5 inches. The cost increase isn't that much. In smaller IDs, if you get larger IDs, you're going to see a little bit of a cost increase just because metal hose and braid costs a little more in those large IDs. Also, on the V connector, we can install them pre-compressed or pre-extended. So, let's say a guided application, if you're going to see all your movement, 2 inches of axial compression, you can take that V, put it in the system, extend it 2 inches, start the system up. When the system starts up, the V is going to take that motion and come back to its neutral state. So it'd be installed like that, start the system up, and now it's just sitting as it was when it had shipping bars on it. And I'll explain what the shipping bars are in a moment. Another great benefit with the V connector and with this new design, there's no pressure thrust imposed back on the system when you start it up. So the V in its neutral state, when it starts up, it doesn't want to extend out like, say, a metal bellows EJ, where if you start those up, you have to constrain the EJ from wanting to push out from the pressure thrust. As well as the spring rate is nominal. We have a 5-inch IDV within our booth, C1913. You can go up to it and go about like that and get that V to start to move in. So it's the weakest point of the entire system, and by weakest point, I'm saying it's the point where if there's forces, that's going to be the point that's going to absorb all those forces when the system starts up or is shut down. With the no pressure thrust and the low spring rate, you also now are reducing the anchors considerably. It's fractions. Within our literature, we have a comparison of anchor loads, so you can see that. Compared to, say, an externally pressurized or a metal bellows expansion joint, something along those lines. Like I said before, we were able to keep the cost of the V exactly the same. And then when we put the V up against an externally pressurized expansion joint, a compensator, or any metal expansion joint, any configuration, the V is always going to be directly comparable and or better priced in every case. And with a lot of those, you're only going to get the axial motion. With the V, you get a lot more forgiveness within the system. I'm going to go through custom fabrication of some 18-inch IDVs we did. I think they were rated for 4 inches of motion. It may have been 3. Here you see an internal weld being done on a large ID connector. We'll do that on large ID connectors, and then we'll do an external weld as well. I want to point out our shipping guys. When we're shipping out product, we know how to get the product put on a pallet, put on a skid, packaged properly to get to the job site so it's in proper working function, so it doesn't get beat up as it's getting shipped. This is just an example of how a large lot of larger IDVs went out about a year ago. Here's an external weld being put on the 45 degree on the 18-inch V and the live length of metal hose and braid. This is that 18-inch IDV going into testing. And you can see the shipping bars in both. Can you guys see that from there? The shipping bars in both pictures. That bar running across from each 45. That's to keep the V in its neutral state as it ships. When it's installed, you take those bars out. If you're installing it in a pre-compressed or pre-extended application, you would take them out before, put it up there and install it, or put one end up, take the bar off, extend it, install it, and then take them both off. This is just a picture to show how big the thing was. I mean, we needed a forklift to move it around the warehouse, so it was a large V connector. And there it is being shipped out on, the two of them being shipped out on a dedicated truck line. So our configurations on the V, there's two basic configurations. The standard V, which goes in line with the system, and then a dog leg. Your dog leg will go in the elbow or the L of the system, and it's working the same way. It's going to be absorbing that offset as that motion starts up. We sold some 10-inch ID dog legs into an exhaust system, so there was no pressure. It was just a temperature issue. When the system heated up to 900 degrees, everything wanted to move. They've been installed. They work perfect. Also, with the V, you're reducing flow loss when compared to a hard pipe loop and or a flexible loop. So your pressure drop across this is a 90 or 45, 45, 90, so it's 180 degrees. With the hard pipe loop or a flexible loop, you're doing 180 degrees because you've got 90 and 90 and 90 and 90. So you're going to reduce your pressure drop through the system. Our options, since we do have such an extensive warehouse, we can do a complete domestic product. If we don't have domestic 8-inch raised face flanges in stock and 316 stainless, it's normally we get it that day or in a 1 to 3 day ship point, so our lead times are still super lean, so we're able to get product out the door fast. All grades of stainless on the metal hose, 321, 304, or 316, or Series 300, stainless steel braid as well. And the end fittings, you name it, we got it in stock. I've done custom machine end fittings for customers as well, so we can get stuff machined. We also, you can put drain ports on these, so if you're installing in this configuration, you shut down a system, all the fluids sitting there, put a drain port on the bottom you can drain out, and or hanging tabs in this installation to hang the elbow. Also on a rooftop application or something like that in an unconstrained system, just pipe supports will be sufficient there. Everything Twin City Hose fabricates, we 100% test. We also have a clean room where we can send the product in, and for high purity applications on water or any type of gases or anything where you just need a clean assembly, because in the natural fabrication of the metal hose, oil's used. So oil is, some oil residue would be in the hose. And then in the fabrication of the metal hose assembly, there's dust. So you may have a little oil and dust in there. Not every application needs that, because when you start up a system, it'll wash it out. But in the high purity, I've done that many times. I want to thank you guys for attending today and making time out of your day to do this, because I know everyone's really busy with meetings and trying to see everyone. Again, we're in booth C1913. Come by and see us. We have a good V display that's going to show an unconstrained system, show nesting, and show the guided system, as well as that 5-inch ID V that you can come up and see the spring rate on. It's nominal. We covered our new hose that we're using, which gave us a smaller footprint, no added cost, no pressure thrust with the V connector, nominal spring rate, small anchor loads, custom and standard movements, endless options of stainless steel, 100% tested, made in the United States, complete domestic product. Thank you.